Math is often called the language of the universe. It maps the movement of stars and planets, the flow of rivers, the growth of living organisms, and it's everywhere we look. But what's fascinating is that even human language, something we think of as purely cultural and creative, also follows mathematical patterns. In this video, we'll explore how the Pareto Principle and Zipf's law reveal hidden structures in the way we speak and write, showing that language itself is no exception to the universal power of mathematics. First, we must travel in time over 100 years ago. It was the year 1896. Vilfredo Pareto, an Italian engineer, was busy harvesting peas in his garden when he made an interesting observation. He noticed that some pea pods had a lot more peas in them than others. On counting the number of peas in each pea pod, he found that 80% of the peas came from only 20% of the pea pods. Now, if there are 10 pea pods, with 50 peas in total, we would expect that each pea pod will have 5 peas in it. In other words, we would expect that each pea pod will, more or less, have the same number of peas in it. But Pareto found that 20% of the pea pods, 2 out of 10 pea pods, had 80% of the peas, 40 out of 50 peas. In other words, 2 pea pods had more peas in them than the remaining 8 pea pods combined. Mr. Pareto was also an economist, and he noticed the same pattern in how wealth was distributed in Italy. He found that 20% of the people in Italy owned 80% of the land. These 20% were very wealthy. The remaining 80% of the population owned only 20% of the land. This pattern still holds true today. In most economies, a small group of people own most of the wealth. Because so many real-world processes behave this way, the Pareto Principle tells us that, as a rule of thumb, it's worth assuming that 20% of the causes are responsible for 80% of the outcomes, like in language, where the most frequently used 18% of words account for over 80% of word occurrences. He and other researchers looked at other datasets and found that this 80-20 imbalance comes up a lot in the world. The richest 20% of humans have 82.7% of the world's income. In the USA, 20% of patients use 80% of healthcare resources. In 2002, Microsoft reported that 80% of the errors and crashes in Windows and Office are caused by 20% of the bugs detected. A common rule of thumb in the business world states that 20% of your customers are responsible for 80% of your profits, and 80% of the complaints you receive will come from 20% of your customers. When analyzing crime statistics, it is generally found that 20% of criminals commit 80% of all the crime. These 20% are the repeat offenders. A book titled The 80-20 Principle even says that in a home or office, 20% of the carpet receives 80% of the wear. Oh, and as Woody Allen famously said, 80% of success is just showing up. The Pareto Principle is everywhere, which is good. By focusing on just 20% of what's wrong, you can often expect to solve 80% of the problems. You may wonder whether the percentages 80 and 20 always apply. The answer is no. It can be approximate, like 90-10 or 70-30. Nevertheless, the principle holds true where a minority of the items will be responsible for most of the output or impact. The Pareto Principle is known as the law of the vital few and the trivial many. It teaches us that there are few things which are very important, the vital few. At the same time, there are a large number of things which are not important, the trivial many. 80% of online content, like this video, is created by 20% of users. It is important to show your support to your favorite content creator, so before we continue exploring the wonderful world of language and math, don't forget to like, subscribe, and leave a comment. Now, we are going to deal with another mathematical principle. About 6% of everything you say and read and write is the definite article the. The is the most used word in the English language. About 1 out of every 16 words we encounter on a daily basis is the. The top 20 most common English words in order are the, of, and, to, in, is, I, that, it, for, you, was, with, on, as, have, but, be, they. That's a fun fact, a piece of trivia, but it's also more. You see, whether the most commonly used words are ranked across an entire language, or in just one book or article, almost every time a bizarre pattern emerges. George Kingsley Zipf, a Harvard linguist, noticed that in a given text, the same words are repeated, so he tried to apply the principle of Pareto to text analysis. In this way, he discovered something entirely different. Zipf realized that there is a frequency pattern followed by words. The most common used word will appear about half as often as the most used. The third most frequent word in a text appears a third of the times of the first word. The fourth 1/4 as often. The fifth 1/5 as often. The sixth 1/6 as often. And so on, all the way down. Seriously, for some reason, the amount of times a word is used is just proportional to 1 over its rank. Word frequency and ranking on a log graph follow a nice straight line, a power law. This phenomenon is called Zipf's law, and it doesn't only apply to English, the language Professor Zipf studied. It also applies to other languages like, well, all of them. Even ancient language we haven't been able to translate yet. Even constructed languages like Esperanto or Tolkien's Elvish languages have a Zipf pattern. Toki-Pona, a language with only 120 words, follows this law too. And here's the thing, we have no idea why. It's surprising that something as complex as reality should be conveyed by something as creative as language in such a predictable way. The world is chaotic. Things are distributed in myriad of ways, not just power laws. And language is personal, intentional, idiosyncratic. What about the world and ourselves could cause such complex activities and behaviors to follow such a basic rule? We literally don't know. More than a century of research has yet to close the case. Moreover, Zipf's law doesn't just mysteriously describe word use. The craziest thing about Zipf's law is that it happens in other areas, not just language. It happens in city populations, the sizes of earthquakes, moon craters, solar flares, computer files, the frequency of use of words in any human language, the frequency of occurrence of personal names in most cultures, the number of papers scientists write, the number of citations received by papers, the number of hits on web pages, the sales of book, music recordings, and almost every other branded commodity, the numbers of species in biological taxa, people's annual incomes, and a host of other variables. Look at this table with the population of cities in my homeland, Argentina, comparing the real number with the one it should have according to Zipf's law. The second most populous city in a country or region has approximately half of the number of inhabitants of the first city. The third city has a third, and so on. There are plenty of theories about why language is Zipfy, but no firm conclusions, and this video doesn't contain a definite explanation either. George Zipf in himself thought language's rank frequency distribution was a consequence of the principle of least effort, the tendency for life and things to follow the path of least resistance. Zipf believed it drove much of human behavior and hypothesized that as language developed in our species, speakers naturally preferred drawing from as few words as possible to get their thoughts out there. It was easier, but in order to understand what was being said, listeners preferred larger vocabularies that gave more specificity, so that they had to do less work. The compromise between listening and speaking, Zipf felt, led to the current state of language. A few words are used often, and many words are used rarely. Recent papers have suggested that having a few short, often used, predictable words help dissipate information load density on listeners, spacing out important vocabulary so that the information rate is more constant. As a bonus, you can check if a text follows Zipf's law on this page. The link is in the description below. I used it to check the script of this video, and yes, everything you are hearing follows the pattern.